Audiences in 2026 have developed an instinctive ability to flag synthetic skin textures and impossible symmetrical lighting. The frictionless, plastic look that once defined AI generation now triggers immediate skepticism. On platforms like Envato, searches for unfiltered content and film grain have surged. The industry has standardized around a new focus: engineering visible humanity and analog decay into every frame. This shift is powered by two frontier engines: Google's Nano Banana 2, running on the Gemini 3.1 Flash architecture, and OpenAI's GPT Image 1.5. Controlling these outputs requires understanding the hardware DNA driving each model. GPT 5.4 operates on a nested linear logic tree, built to maintain strict adherence to complex instructions. Gemini 3.1 uses a multi-node web structure, built for spatial mapping and real-time data grounding. Because photorealism is now a standard feature of every model, a creator's value is found in manipulating these architectural differences to create intentional visual friction. One of the most persistent issues in generation is prompt bleeding. This occurs when a model accidentally mixes the attributes of two subjects, like giving a character's red hair color to the background walls. OpenAI addresses this by using GPT 5.4's thinking mode as a virtual creative director. The model pauses to map out the prompt's logic before a single pixel is rendered. This logic flowchart isolates variables. By placing subject A's attributes in one bucket and subject B's in another, it prevents visual contamination. When a generation fails, engineers deploy the O3 model to debug the reasoning path and identify exactly where the logic broke down. Google uses a different mechanism to handle constraints. The Gemini architecture utilizes a thinking level parameter to prioritize spatial precision. This geometric grid demonstrates how Gemini maps out a 21:9 frame. It calculates mathematical bounding boxes to manage negative space and subject placement with high precision, allowing the model to natively generate complex layouts tailored to the frame, rather than simply cropping a square image. In practice, this means routing multi-character narrative tasks to ChatGPT, while sending precise spatial and mathematical layouts to Gemini. Standard 1:1 square generations have been replaced by native 21:9 ultra-wide and 9:16 vertical outputs. Managing these formats requires a rigid 6-part prompt framework: subject, action, style, camera, lighting, and extra details. The camera and lighting variables dictate how the model calculates depth and edge details across wide formats. These instructions can be used to simulate specific anamorphic lens flares within the latent space. This cinematic still demonstrates the effect of requesting a specific f-stop, like f1.4. It forces the algorithm to calculate optical blur based on physical distance, rather than applying a flat post-processing filter. Treating the text prompt as a literal physics engine is the only way to achieve professional-grade cinematic depth. Avoiding sterile, generic AI looks requires specific style signals to force the models into obscure sectors of their training data. One major trend is code brutalism, often paired with a surveillance aesthetic. The master prompt calls for terminal UI overlays, incorporating heavy scan lines, aggressive chromatic aberration, and monochrome green palettes. GPT Image 1.5 is the preferred engine here. Its narrative adherence ensures UI code stays sharp and legible, never melting into the organic subject. A second trend is tactile maximalism, a core part of neo-surrealism. This aesthetic places electric neons against physical materials like fur, chrome, and biomorphic geometry. Realistic rendering of these materials requires the prompt keyword subsurface scattering, or SSS. Gemini's Nano Banana 2 is the better choice for SSS, as it effectively calculates how light penetrates and scatters through translucent surfaces. Finally, the high-velocity Italian brain rot trend has dominated social platforms. This style requires exaggerated pinched finger gestures, smartphone camera aesthetics, and high-velocity motion blur. These motion parameters establish the visual vectors needed to turn a still image into expressive, motion-driven clips in downstream video generators. Success in 2026 is defined by linking specific lexical triggers to the architectural strengths of the underlying hardware. For years, AI image generation was limited by two weaknesses: the inability to render accurate text, and the lack of reference to current events. Gemini 3.1 solves this by combining real-time web grounding with sharp typographic rendering. This diagram shows how the model can search a live dataset, like the current S&P 500 tech performance, and pipe that data directly into the generation node. The model synthesizes this information into a visually accurate, typo-free infographic in a wide 21:9 format. Gemini can also instantly localize these designs, translating embedded text into over 10 languages while maintaining the original layout and typography style. This capability enables the creation of real-time, data-driven visuals for a global audience, where text and data stay synchronized with the live web. Use ChatGPT 5.4 when you need deep narrative adherence, complex multi-character logic, or conceptual brainstorming. This split-screen matrix summarizes the choice. Route to Gemini 3.1 for precise cinematic aspect ratios, flawless typography, and live data integration. Choosing the wrong engine for a specific technical task leads to aesthetic failure in a professional pipeline. Because basic photorealism is now standard, simply generating a clear image is no longer a high-value skill. The value of a digital art director in 2026 is found in the ability to architect intent, curate intentional imperfection, and command these mathematical engines with precision.